the enjoyable topic in terms of, making our mind think, and also in terms of making our class goals, our understanding of operating system become deeper and deeper. So I would like to start with the definition. What is a deadlock? When do we have a deadlock? Because it's a very, very essential to understand. But I will not go, or I will not jump into this deadlock without passing through some of the core basic which I expected you to highlight in operating system in terms of, in your group project, but somehow you didn't mention it. So I will cover that and then we come to the deadlock. All right. So now the objective for this one, just want to illustrate how a deadlock can occur. Please remember the main objective of this is just to know how a deadlock can occur. I just want to know. Yes, you. As I'm making this one, I just want to know how many of you go through the video. How many of you revise? For which one? This one. For the classes. Oh, yes, please. Very well. Very good. So if you find any difficulty or something which bothers you, please don't feel shy or hesitate to ask me if you don't understand. So now we look here how deadlock can occur. We again define the 4 necessary conditions that characterize the deadlock. We also identify the deadlock situation in the resource allocation graph, and we evaluate the 4 different approaches of a deadlock. And also we try to understand something called the banker's algorithm for deadlock avoidance. All right, that's what we will do. We also apply the deadlock detection, and we will evaluate the approach for recovering from deadlock. But as for today, we will illustrate how deadlock can occur and the different 4 necessary conditions that characterize deadlock, right? And identify deadlock situation. So we take these 3 points only for today, and then the next class we will cover the rest of them. All right. Now I start with the duty of graphical user interface. Does anyone know the duty of operating system? Sorry, maybe I mentioned OS, graphical user interface. The duty of operating system. Pardon me. Those 2 things were in my brain. What is the duty of operating system? Okay. The main duty of operating system, as you may say, it's just to manage the resources, to manage the software or the application which are within a computer, and also to manage that we can call the hardware. So here I will point back to this one after understanding the duty which we have here. Now, the duty of operating system starts from here. I want all of you to think about applications. Okay, we have the applications in your system, and every application has operating system. Now again, the question comes, what is operating system? What is OS? Operating system can be defined as a set of programs which governs the computer, right? So every application, or do you know that the mobile application, they're also the computers, the electronic devices, right? But many times we consider the computers as this device which we have here. So as you can see here, we have a different operating system. We have Mac OS, Android, we have the Windows, we have the Ubuntu. So many applications are there, right? So many operating systems. Now, any operating system which is listed here, the main purpose is to manage. What is going to manage? It's going to manage something which is called UI. UI is user interface, right? User interface. Now, what is the purpose of a UI? For the user to use the function, right? Or to access the applications, right? Now here, look here. We have a different applications, right? We have various applications. We can call games, camera, download, upload, listen to music. So many applications are there in your devices. Now, all these applications, they need what? They need to access operating system, but they can't do that. They need to pass through what? User interface, and the user interface is going to tell the operating system, please respond to the request. So, for example, I have the user interface. Let me navigate here. For example, these are my interfaces which I have down here. Do you see down here my arrow? It's navigating here. Down here. These are my interfaces which I have here. Right? So when I click to this one, just operating system, the user interface is going to send a request to operating system to the UI. Just it has to change this cursor into razor light. Okay, so we take this application, and this application, they need to pass through the they need to send a request to the operating system through user interface. So any application which you have here, they are made or they're built into software, into the programs. So if you learn Java, if you learn C++, all those programming language which you're learning, you can create the application. And application, we need user interface or UI. Maybe in the next class, when we next semester, when we talk about human and computer interaction, we'll focus more on UI. So this is the best or the main point which you need to understand about the duty of operating system is to manage user interface. And this user interface, they're very helpful to accept the request of what? Application which need to access to the operating system. Okay, this is it. The next point which I want to mention here is something called system call. The system call. What we mentioned in the previous here was something called to send the request. You understand? There is a send of the request. There is even a response of the request. Now here, when we say a system call, by definition, it says a system call is known as a programmatic way in which a computer program requests what? Service from what? From kernel of operating system. You understand? A system call is when we send a request A request is going to be sent, from the kernel. Now you may ask a question, what is a kernel? Did you mention about the kernel in your presentation? No? This is a very, very fundamental point to understand in operating system. Define a kernel. What is a kernel? You cannot escape it in any exam or any interview when you approach any company if you say that you have knowledge in operating system. So system call, this is like deep definition. But in a narrow definition, a system call is a way for programs to interact with the operating system. I want you to relate to the previous one. We have operating system, which manages what? UI, and we need application to pass through UI to access operating system. So all these requests, they are known as what? System call. They come under system call. A system call is a way for programs to interact with operating system. So to interact with the operating system, we need to have this concept which is called system call. But your supplies, not all, in a previous class, we learned something called trade and process. Do you remember? In earlier class, I mentioned something called trade and what? Process. Okay? I even asked you what is the difference between a trade and a process. If you forgot, don't worry. We'll again, revise once again that. So trade does not need to have this system call, does not send a request. That's what we'll see in the next part. And also, one more point here to understand about the system call. I think that's the point which I mentioned there. I highlighted this one just for you to look at the focus of the point which I want to mention. That computer program send a request services from the kernel to operating system. Now we are going to look, kernel. What is a kernel? This definition, I don't want you to forget, because from the time I learned, it was like in 2009 or 10, when I was taking this course of operating system, I still remember this definition. It's mentioned, kernel in a computer program, right, is a computer program that is a core or a heart of operating system. I have never forgotten. Even if you wake me up in the middle of the night, what is a kernel? It is the heart of operating system. That's all. So if operating system is a body, then the kernel is a heart. Okay? The kernel is the heart. So in order for a computer to work, it must have operating system. In order the operating system to exist, it must have what? Kernel. So you cannot separate these two. Now, I will show you what the kernel does, right? Here we have the application or software. The software which you have here, they need to access, they need to get the response from the kernel. What is the purpose of a heart in a human being? Pump blood. Okay? Pump blood. Right. I just want to ask you one question. Maybe you may have heard about it, right? Before a heart and a brain, when a person dies, which one dies first? Is it the heart or the brain?
How that person die? How that person die, like diabetes or like accident or
in any normal, because a death is a death. Even if they cut you the head, if they chop your head, which one will die first?
baby brain? Because
It's a debatable. People debate about this because we know heart function, right? We have a heart attack. If your heart attack or heart panic, it's just not functioning well, but does not stop. Heart is organ which start to work till you die. It never stop. It never stop. No rest. Brain is a part which always keep working as well. Maybe it take a rest when you are sleeping, just changing the activities, right? To shut some of them, like seeing, like, some senses, it goes down, but brain keeps working. Now the question is, which died first? Because if you go to hospital, they just look the heart rate, right? When they're putting the pulse here in your heart, this is the person's fine. If it's line, means the person's gone. But it's keep going like this, life is there. When you are in coma, or somebody's in a coma, is the heart working or heart is not working? Heart works. What is not working? Very little cannot, the remembering cannot be there. But if you go in a deep science, people say that the brain is the one which dies last, though the heart stops. But we say if your heart stops working, you die, but still the brain. So it's a part of that one. So here we have the application, the software which we have here. So Kernel is a heart. This heart, there's also something which says, I'm sorry to mix this one. I hope you like the stories, right? You like the stories. I love stories a lot. And if you want to know more stories, read the Bible. You will find so many stories, interesting stories. There was a time Jesus was accused, right? Take it as a story. It's related to this one, okay? The Pharisees came to him, give him a bad comments, like the one which you may give in the course evaluation somewhere. So tough comment. They gave Jesus bad comment, and it just says, "You want to kill me? You are of your father." They said, "Who is our father?" "Our father is Abraham. Our father is Jacob." And Jesus Christ said, "You are doing out of your father because you want to kill me." And they asked, "Who is our father?" Whom Jesus Christ said, whom Jesus Christ has replied. After they said their father is Abraham, do you know whom Jesus Christ has said? He said, "Your father is a Satan devil." Because always the devil thinks, or his heart is about killing. And they were very offended. They said, "How come?" And he again goes deeply, says that what heart desire has to produce it. What is in your heart, you will give. You understand? What is in your heart, you will give. So here, Kernel is a heart which helps all application to work. They request the services and is going to respond to the services. So now look here. Look, all applications which are managed by the Kernel. Processors, memory, disk, devices, all this software, as you can see them, all these software which you can see them, they are all governed by the Kernel. There is a book which I want to recommend you to read if you get a time. It's a book which is called, the Bible is number one, yes. After that one, there's another book called Mind, Character, and Personality. It talks about, heart and the mind. It's the same concept like this way. It's same concept, right? Same concept. So Kernel, it governs all these things which are there, right? And also Kernel needs this to live, to survive, right? Such as a mind needs a brain, and the brain needs a mind. A brain without mind it cannot work. And the mind without the brain, it cannot work. So same way here, kernel needs processors, needs a memory, needs a disk, needs devices in order to function, right? So hopefully you understand, the meaning of the kernel. What is a kernel? A kernel is what? Heart of, yes. What is operating system? It's a body of kernel or operating system. Maybe it's not the operating system. It can be like, it's a body of the kernel. Yes, that's what we can put. But technically, operating system is a program, a set of programs which governs how a devices can function. If I say computer, I will be limited. Okay, because as you have seen, your mobile application, your mobile phone has what? Operating system, right? So if you read in many books, they give operating system as program which governs the computer. It's not limited to computer. It's for all the devices. So now look here. Another definition. When you are going to the football ground, whenever you see the pond, please remember the kernel. Okay, there is a small bridge. A bridge. If you pass this way near the back station, right? Have you crossed that bridge?
Yes.
Going to the gymnasium. So a kernel is a bridge between application and data processing done, right, at the hardware level. It's a bridge between application and the processing, right? Data processing, right? Now, again, here it's mentioning that it is a central component of operating system, right? It's a central component of OS. It's going to bridge the hardware and also the data processing application, right? Which may reside in your computer. And in order to process this data or this application, what do you need? If you want to access application, what do you need? UI. You need a UI. Otherwise, you're going to use CLI, C command line interface, CLI. Okay, so this is it. So one more point to understand, it is the part of OS that always resides the computer memory and enable communication between software and hardware. Just I made in a different way so that you can understand, you can get at least one meaning or two meaning. If somebody asks you, discuss about operating system or kernel, you can have a lot of information. Okay. Now we have a different types of kernel. There are 4 types of kernel. We have 4 types of kernel. These 4 types of kernel, they work in a different ways. Okay. We have monolithic kernel. We have micro kernel, hybrid kernel, and nano kernel. If you go down somewhere, you may find, keep naming different kernels, but the prominent, the useful one, I only focus on 3, the first 3 ones: monolithic kernel, micro kernel, and hybrid kernel. Okay, these are the 3 main kernels which are used. Now, look, the monolithic kernel. This is the monolithic kernel. So, monolithic kernel, the same memory space is used to implement user services in the kernel. So here, it's about where the kernel is resides. Does not separate the services and the kernel activities. They all reside together, right? If you look, for example, Unix and Linux, they are what? Monolithic kernel. And operating system Do you know that C programming language is used to build operating system? C programming language, first language to develop operating system, to create operating system which you have in the system. Okay, and also Unix programming. Maybe I will suggest before we go to the Linux, you can study Unix because they are somehow different. One is old version, another one is latest version, right? So it's very nice to understand this one. And I thought of introducing to you C language at least, or Unix, but I'm afraid that it may be too much for you to digest or to take it. Maybe we can have a next part 2 of the class, which can focus on the Unix and then go deeper. Because the process which we created, which we calculated, we can implement, we can create them in a programming language. Maybe Mr. Fanindra, I will talk to Mr. Fanindra, your teacher, to include creation of the process in your class stage of computing, right? So you can create process and then implement those algorithms which you have studied in the previous class. So here we go on. This is monolithic kernel, and we look another one which is known as microkernel. Microkernel. So the microkernel, as you can see, this microkernel, we have a separate services, right? Here it's going to separate the services. So the first one we saw, the services and the kernel, they are, they are going hand in hand, right? They go hand in hand. So, but here it's separated them. The kernel is separate. The server, the software, we have like the separate servers, right? Kernel can access the memory differently, and also the software, the application can have its own different application. So another kernel which we can think about is a hybrid. So in a hybrid, it's when we combine both kernels, both types of kernels, monolithic and micro, right? When you combine, then you have hybrid, right? So do you remember the hybrid mode when COVID, tried to reduce? We have a hybrid mode. Means some students are online, others they are on site. That's called a hybrid. So here, hybrid, we combine two kernels, two types of kernels, monolithic and what? Microkernel. Now here in this microkernel, just we combine both, and these are the examples of hybrid kernel. MS Windows or Microsoft Windows, it's a part of what? Hybrid kernel. Okay, hybrid kernel. So these are the main points which you need to understand in a kernel before I touch the last point of the kernel. Anyone has a question?
The second one, which is the microkernel and hybrid kernel.
Which one?
And it's like in the first one, there's like hardware also, right?
Yes, software, kernel, and hardware, right? Okay.
The second one, where it's like the hardware part.
Because here, in a second way, it's separating them, right? The hardware part will be accessed separately. For example, if we include here, we have a software, right? Let's say the hardware may be down here, just to access either to the server. Yeah, it was omitted in the case of emphasizing the services provided internally. For the first one here, just to show the basic one, because this is useful one or understandable by all operating systems. Yeah. This is the second one. Good observation. Now, this was the third one. Now, come to the last point here of kernel. Something called kernel.
So, first kernel.
Nano kernel, as I mentioned, the nano kernel, it's still under development. Three of them, the three, I mentioned 3, right? So listed 4, I mentioned that I focus on 3, which are very useful, right? Which are very useful. Nano kernel, still in the development, people keeps, using under development, right? So that's called the nano kernel. And if you look, nano is below micro. Micro, nano, it's just maybe small one for IoT. They may be focusing on that nano kernel. So I come to this one. I'm going to give you a hint. What is heart panic or heart attack?
I think it don't know what to do in that situation, so it start to panic.
Start to panic, right?
Maybe it can like define for output but no input, or maybe have input but don't know where to output.
Very well. Now I'm going to give you the meaning of kernel panic and try to relate it to heart attack. Okay, I want you to speak out about a heart attack, right? So look here. You read it. Okay, what you mentioned was correct.
Safety measure.
Safety measure. Kernel panic. Can we relate to the heart attack?
Yes, before heart work too much,
Mm-hmm.
heart fail,
Yes.
everything down.
Yes, everything is down, right? Same way here. Kernel panic is when the kernel is not able to do its job proper, right? When it fails, then everything is going to be not fine. Sometimes you own the operating system, right? And it does not respond. It sends you blue screen. When it sends a blue screen, what happened? It is giving you signal that it's not well functioning. That is a part of what? Kernel panic. In Ubuntu, sometimes in Ubuntu, it's not working, right? It's kernel panic. So you face kernel panic. Yes, it's not, giving you the desirable output.
So in window when system is not responding, it means kernel panic.
Yeah, it's under kernel panic. It has gone under kernel panic, right? So how to recover from this? You either reboot your system, or restart your system again. So from that time, the kernel thinks, okay, let me connect, right? So this is the part of kernel operating system. Any question before I start the deadlock? Any question? Okay. So if there's no question, then you are going to look to the deadlock, right? These are points which I will ask you in a final exam. These are very useful. You need to go through this, study them again, and then understand how the concept, so that you can be able to meet the demand of the exam. All right, so now let me come to the deadlock. I want to give you the definition of deadlock, and please never forget it. And my request to you once again, please have the best habit of using your pens. If you don't use your pens, I'm very scared. Pens, I just want to mention, pens, it's something, it's old style, but it's really useful all the time. When you write, it registers your brain. And when you write with your hand, you remember where it is. It helps you a lot. It saves me a lot. So please have the habit of writing down, so that you can remember what you have learned. Let me give you the definition of a deadlock. Please don't forget. Now you will go to Mr. Fanindra or to your teacher and say, I know deadlock. I know what it means. Okay. Now, this one is related to what we have seen in the previous class on processors. Deadlock. Deadlock in operating system occurs when two or more processes are unable to proceed because each is waiting for others to release a resource. Connect dots. Dots of the previous classes. First come, first serve. Shortest job, fast, or fast, shortest job fast, right? SGF, right? Shortest job fast, right? Or round robin. You understand now? Processes are coming, right? Now, take an example now. If Mr. Piranat goes, I was going to mention something, but okay, let me take myself. I'm going inside the bathroom and all of you are waiting. I'm not coming, right? I stuck there. I sit. You went to Anna. Oh, why this man is not coming from there? You know, I say, man, I'm urgent. Take the same example, right? This is a deadlock. Processes. Consider yourself as a process, right? You're all urgent, right? I gave it this weird, but take it, right? You all need to visit it, right? You're on a queue. You want to use it. I'm still. That's called the deadlock. Two or more processes are what? Are in need of accessing the resources, but one is stuck. What to do? You remember round robin, right? Every process has what? Counter, yes, counter time, right? Now imagine if your counter time exceeds and it's not coming out. What would you do? What process will do? Oh, I want to access. No, counter time is still stuck there. I don't know. First come, first serve. You fast, you're going there, but you're not leaving. You're still there. Shortest job fast. You came as a first. I don't want to go. Those are what? Deadlocks. When a process is not letting others to access.
Is there also not work, but
Yes. Yes, it was occupied the spaces there. That's called a deadlock. Understood?
Yes.
Very well. Now look here, the same concept is here. But mainly this is mentioned about the threads. Okay? When a thread or a process, they share the same memory. Remember, thread is what? Thread share what? Memories. Okay? But process, they may have a different memories. So these are the threads which you have in here, multi-thread. So we look here, the definition of this one. Several threads may compete for a finite number of resources. Look here now. This is important. A thread requests for resources. What will happen? If resources are not available at that time, the thread enters waiting state. Understand? Flashback or reflect back to the previous class, right? First come, first serve, or the best one. Round robin, or the best one. Shortest job fast, or the best one. Shortest remaining time, right? Take any of the process. You remember process ID, P1 came, arrived at this time with what? Burst time. But it does not want to come. P2 came at time 2. What will it do? It goes to where? Waiting room, waiting queue. Or for those who flies, How do we call the waiting room for the passengers? Huh? Robbie, right? Do you know Robbie? Robbie is the waiting area, right? You have the Robbie. When you have a transit, they give you Robbie, right? You go to the Robbie where you can wait for a certain time. So you be in a Robbie until your flight arrives and then you can fly. So same process is here. If a resource is not there, there is going to waiting room or waiting queue. Please remember the life cycle process. Process life cycle, right? Where do we start from? Ready, start, ready, running, waiting, and then what is the last one? 10 minutes. Keep remembering there. But before 10 minutes, it can be, suspend. It can be waiting. So I believe now when I mention about suspend in round robin, it's suspended, right? Remember round robin? For the time quantum, the process is going to be suspended, right? You were running, suspend. And again, come back. Suspend until it finishes its all bus time. Is it clear? So now let me give you a break. So after the break, then we shall see the following points. After the break, we'll see the 4 conditions, characteristics, and then we identify, we finish. Now, can you illustrate how a deadlock can occur? Can you illustrate? Now, after the break, I want you to draw with your imagination what a deadlock can be. Okay? Anything which you have in your mind, how do you understand deadlock? Draw it. All right? For now, you can take your break. And I will take a photo of them. I will take the photo of them of your imagination of deadlock, and I will post. Please do it. I'll post in a group.